Good evening, friends. We were on these topics, area of triangle, for a few days, and now we have come almost to the end of these topics. And today I will give you some idea about 2 or 3 sums, some tricky sums. As I told you earlier, that each and every sum is not possible to solve. It will take a huge time. And basically, I once again tell you that I am conducting this teaching session for the students who have the basic ideas, so that I need not mention each and every basic formulas all the time. So here, you know this centroid of a triangle. I think most of you have an idea about those centroid of triangle, but still I am mentioning what is the median of a triangle? A line joining the vertex and the mid of the opposite side. That is called median. So as there are 3 sides in a triangle, so there would be 3 medians. Here is a triangle ABC, and medians are AF, CE, BG respectively, because from A the line drawn to the mid of BC, that is BF equal to AC, FC, BF equal to FC, similarly BE equal to AE, AG equal to GC. That's the midpoint. G of AC, E is the midpoint of AB, and F is the midpoint of BC, and joining these bodies we get the medians. So these median, 3 medians intersect at a point O. This is called the centroid of the triangle. O, where the 3 medians intersect. Where the 3 medians intersects. Three medians intersect at this point. AF, BG and CE, BG and CE intersect at O. So O is the centroid of a triangle, and here is also the measurement. I think that is also known to you. Some of you know that there is the ratio. This is centroid and this is the median, and this ratio is AO. If there is the point, we can take H. Suppose, so if the median is divided into 3 parts, then it is seen that this centroid is 1/3 at this point, 1/3 of the whole median. So the distance between the vertex and this centroid equal to 2/3 of the median. Suppose the median is 6 centimeter long. So this distance AO would be 6 into 2/3. That means 4, and these would be 2. So that's why I told that 2 the thrice. It's a sectional length, and AO is 2/3 of the median AF. So if AF is 6, then AO would be 2/3 of the median, and this length is 1/3, as I told you earlier. OF, this is 1/3. The total length is 3. This is 1/3. Total length 1. This is 1/3. This is 2/3. Okay, so that's the main point for the centroid and the medians of a triangle. Medians, as you know what is median, and these three medians in a triangle where it intersects, that point is called centroid, and the vertex and the centroid, the distance between vertex and the centroid is 2/3 of the length of the median. What is the length of the median? We take it, and if we multiply it with 2/3, then we will get this length AO. Now we come to the particular sum. Here is a triangle, and the distance between the vertex and the centroid is 4√3 centimeter. This length 4√3 centimeter. AO equal to 4√3 centimeter. We take it as for the median AD. You can take this one if you rename it BE, CA, whatever it. But I draw here one median to avoid complications, because the picture will be much complicated, or so that's why I have taken only one median, and the distance between the vertex and the centroid is 4√3, and it's an equilateral triangle. It's an equilateral triangle. That means all the sides are equal. Equilateral triangle, and the distance between vertex and the centroid is 4√3. And what is wanted here? Then what is the area of the triangle? What is the area of the triangle? Now we know for equilateral triangle, as you know, ABC, we took it length of the sides as A. So there is the basic formula √3/4 A square. It's the area of the any equilateral triangle. And what I mentioned just now, that in case of centroid, distance between the centroid and the vertex, it is 2/3 of the median. And for median also, there is the formula median for equilateral triangle equal to √3/2A, where A is the side. Median of equilateral triangle √3/2A, and area of equilateral triangle equal to √3/4 A square. So now the distance between the centroid and the vertex is 4√3, and we know this distance AO is 2/3 of the median. So AO equal to 2/3 of what? Median. AD equal to 2/3 of median's formula √3/2A. AO equal to √3/2/3 into √3/2A. So here it is √3/3A. So AO equal to 4√3, it is given, and ABC we know root 3 by 4 a square, and AO equal to 2/3 of the median, as I told you earlier. So 2/3 into AB's value is root 3 by 2A. So root 3 by 3A. So by the problem, it is the value of numerical value what is supplied to us is 4 root 3, and here we deducted this value. So root 3 by 3A equal to 4 root 3. So A equal to 12 centimeter. So A equal to 12 centimeter. And what is required? Area of ABC. Area of ABC, it was required. So A's value 12, 12, 12, all these sides are 12. And what is the formula of area? Root 3 by 4 into A square equal to root 3 by 4 into 12 into 12 equal to 36 root 3 square centimeter. This is the area. So when A equal to 12, so area of ABC equal to root 3 by 4 A square equal to root 3 by 4 into 12 into 12 equal to 36 root 3 centimeter. So that's the sum. Here is the equilateral triangle, and the distance between the centroid and the vertex is 4 root 3 centimeter, and we are required to find the area of the triangle, equilateral triangles. Equilateral triangle, for equilateral triangle, the median is root 3 by 2A, and we know the between the center, distance between the center and the vertex, what is given here, it has the formula root 3, 2/3 of the median. So 2/3 of the median, so it is median, so 2/3 of root 3 by 2A, we mentioned there, it was root 3 by 3 by root 3, and then we equated this with this numerical sum equal to that, we get the value of A, and it was 12. So easily we could find out the value, area of ABC by using the formula root 3 by 4 square equal to 36 root 3 per centimeter. I think it is clear to you. Now another sum. ABC is a triangle, and from any point in the triangle, 3 perpendiculars are drawn on the opposite sides. Three perpendiculars are drawn on the opposite sides, and what we require to find out is the perimeter of the triangle, and what is given here, the length of this perpendicular drawn, and it is 6, 9 and 12 centimeters. So here is the triangle ABC, and from any point inside the triangle, 3 perpendiculars are drawn on the respective opposite sides, and they are OE, OF and OG, and their lengths are given 6, centimeter, 9 centimeter and 12 centimeter respectively. Now what we require to find is the perimeter of this triangle. For this sum, as you see that whenever we use some area formula, it is required everywhere, every sum, in every sum almost. So there is a height, there is a base that's are required. So here this picture is not seem to be completed, because if we join this line, if we join this intersecting point with the respective parties, then the picture is completed. Like that, you imagine a triangle BOC, then there is a height, there is a base. Similarly, if you take AOB, there is a height, there is a base. If you take this triangle AOC, there is a height OF and there is a base AC. So it needs to be drawn, that is from the intersecting point to the respective vertices we draw 3 lines. Now the picture is complete and we can proceed easily for the sum. Now these triangles, another characteristic that I forgot to tell you, that is it is also an equilateral triangle. It is also an equilateral triangle. So all the sides of this triangle are taken as A here, suppose. So the area of this triangle equal to, we know the basic formula, √3/4 a square centimeter. Area of this triangle. Area of this triangle, what we require to determine is perimeter of ABC. That means whenever we can find the value of A, we can easily find the perimeter or area, whatever it is required. So now the overall ABC's area is √3/4 a square. Now what we told you earlier, that there are 3 triangles. If I take this triangle, that was our motive. Why we drew these lines? Because these were our motive, that there is 3 triangles BOC. We can take 3 triangles. More triangles are there, but the convenient for us, there are 3 triangles BOC, AOB, and AOC. For those who we are getting a height, that perpendiculars given by the sum 6, 9, 12, that is to be used as height, and the bases are there already. It was all A. So area of triangle BOC, but BOC is not an equilateral triangle. It is normal triangle, and here is height and here is base. So its area is half into base into height, half into base BC, A into height 12. So 6A square centimeter. Similarly, area of AOB equal to half into base AB, it's also A, and height 6. So 3A square centimeter. And area of AOC equal to half into base again A into 9 equal to 9/2 A square centimeter. So that the area of the 3 triangles are 6A square centimeter, 3A square centimeter, and 9/2 A square centimeter. And these triangles are within these very triangle, that big triangle. So if we add them, we will get this big triangle. So this is our clue. So we can write by the problem 6a plus 3a, 6a plus 3a plus 9a by 2 equal to root 3 by 4 square. I think it is clear. This triangle 6a, this triangle 3a and this triangle 9a by 2. We have made addition equal to the whole area of this triangle root 3 by 4 square. So now by solving we get (27a by 2) equal to root 3 by 4 square. So 2. So root 3a by 2 equal to 27. Root 3a by 2 equal to 27, or a equal to 27 into 2, 27 into 2 by root over 3. 27 into 2 by root over 3. But you know, we have to rationalize it, because normally it is not, we should not keep any irrational value in the denominator. So we rationalize it. 27 into 2 into root 3 by root 3 into root 3 equal to 9 into 2 root 3 equal to 18 root 3. So A's value is 18 root 3. Value of A is 18 root 3. So what is the perimeter? 18 root 3 into 3, that is 54 into 3. It is very clear. So here is a triangle, equilateral triangle, and the length of the perpendicular drawn from any point within the triangle was 6, 9, 12 centimeter, and we are required to find the perimeter of the triangle. What we did was to join AO, OB, OC, because we want to get some triangles with base and height so that we can easily derive the areas. Now the whole triangle's area was basic formula root 3 by 4 square. A was unknown to us, and for these little triangles, for BOC, we applied half into base into height. For this one, and we added it to equate with this, and from there we got the value of A as 18 root 3, where A equal to 18 root 3 sides. So perimeter equal to 3 into 18 root 3. So 54 root 3